My dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about subject signals and systems, and today's topic properties of jet transform we are going to see. And before going to discuss properties of jet transform, all of you subscribe, share the channel. This channel is very helpful to you. Let's start our session. Properties of jet transform. Properties of jet transform. Very important. Properties of jet transform. Properties of jet transform. So the first property, linearity. Number one is linearity. Linearity. So first we discuss definition of property, then we go for proof. The definition is, if x1 of n z transform is x1 of z, ROC R1. For example, ROC is R1. x2 of n z transform is x2 of z. x2 of z, ROC is R2. Its ROC is R2. Then linear combination of these two signals means A x1 of n, B x2 of n. So for this combination, the Z transform is A x1 of z plus B x2 of z, and ROC is intersection of R1 R2, or common ROC of R1 R2. That is a property, linearity property. Let's see the proof now. So almost all properties are proved with the help of Z transform definition or Z transform formula only. So Z transform of x of n is equal to x of z is equal to summation n is equal to minus infinite plus infinite x of n z power minus n. This is the formula. Now we take the Z transform of this linear combination. Now Z transform of A x1 of n plus B x2 of n. Its Z transform will become summation n is minus infinite plus infinite. So here also A x1 of n plus B x2 of n, B x2 of n z power minus n. Now we can write separately. A is a constant, write outside. Summation n is minus infinite plus infinite x1 of n z power minus n. B also constant, we can write outside. Summation n is minus infinite plus infinite x2 of n z power minus n. Now by comparing these summations, these two are Z transform formula, right? Like Z transform formula only. Okay, here x1 of n Z transform, this is x2 of n Z transform. So we can write A x1 of z plus B x2 of z. This is the proof, simple. Just Z transform formula, then take the linear combination of x1 of n, x2 of n, we get. Next, another property, second one, time shifting property. The second property is time shifting property. Time shifting property. We see the definition first. If x of n Z transform is x of z, x of n Z transform is x of z with ROC R, for example, then time shifting means x of n minus k. It's Z transform. X of n minus k Z transform is x of z into z power minus k. So z power minus k is coming extra. And what about ROC? ROC is same as R except z is equal to 0 because of this z power minus k. Except z is equal to 0. Now see proof this property, time shifting property. As I said, z transform of x of n, signal x of n is equal to x of z is equal to summation n is equal to minus infinite plus infinite x of n z power minus n. Now take LHS, that is z transform of x of n minus k. So z transform of x of n minus k is equal to summation n is minus infinite plus infinite x of n minus k z power minus n. Okay, so here some simplification. What is that is, let n minus k is equal to m. I am taking variable m. By this n value m plus k, or n will become m plus k. And if you see limits of m, lower limit, upper limit, so we have m is equal to n minus k. So here we have n limits. Lower limit is minus infinite minus k. M lower limit minus infinite. Similarly, upper limit. So upper limit is m is equal to n minus k. Upper limit of n in plus infinite minus k. This will be plus infinite. So all these we are going to substitute in this summation. By the substitution, now summation m is equal to minus infinite to plus infinite. Here x of m, because n minus k is m, and z power minus n. Here n, what is n here? M plus k. Write that m plus k. So z power m plus k we can write as minus m plus k. Z power minus k we can write outside because the summation is m. So m is minus infinite plus infinite x of m z power minus m. This summation now, it is like, this summation is like z transform formula, right? Just to do comparison, you can understand. So therefore the result z power minus k into z transform of x of m, that is capital X of z. This is the answer. So z transform of x of n minus k, z power minus k x of z. Similarly we can write z transform of x of n plus k, z transform of x of n plus k. How much you can expect? Answer z power plus k into x of z. Z power plus k here, because n plus k, n minus k, z power minus k. So this is the time shifting property clearly. Next, third one, time reversal property. Time reversal property. Time reversal property. So first see the statement, time reversal property statement. If x of n z transform is x of z, x of n z transform is x of z with ROC R, then time reversal means x of minus n. Time reversal means x of minus n. Z transform is x of z power minus 1 or xz inverse, and ROC will become 1 by R. ROC is 1 by R. This is the time reversal property. Time reversal property. Let's see the proof. So first we take the Z transform formula. Z transform of x of n is equal to x of z is equal to summation n is minus infinite plus infinite x of n z power minus n. Okay. Now we want Z transform of x of minus n. It's Z transform. So I'm going to write that. So Z transform of x of minus n is equal to summation n is minus infinite plus infinite x of minus n z power minus n. Okay. It doesn't mean that n is minus n, because here we have x of minus n Z transform, therefore x of minus n here. Let's see simplification. Let minus n is equal to m, and n will become minus n minus m, and limits lower limit upper limit. So m is equal to minus n, the lower limit of n minus infinity, so minus of minus infinite plus infinite. Similarly, upper limit m is equal to minus n, upper limit is plus infinite, therefore minus infinite. Now all these are going to substitute in this integral, sorry, not summation. Now this summation will become summation here m, lower limit plus infinite, upper limit minus infinite, x of m and z power minus of n is equal to how much? Minus m. Okay. Now this is the summation. We can exchange the lower and upper limits, no problem with the limits. We can exchange minus infinite to plus infinite, x of m z power, or z inverse I am writing as z inverse power minus m. Okay, now we can write like this, z inverse power minus m. Both are same. These two are same. Now by comparing this with Z transform formula, what will be get? What will be obtained? This will become Z transform of z power minus 1 or x of z inverse, right? In the place of z we have z inverse, therefore x of z inverse, x of z inverse, simple. Next, go to fourth property, multiplication by exponential. That is the fourth property, multiplication by exponential. Multiplication by exponential. By multiplication by exponential. This is the property, fourth property. Now the definition is, if x of n z transform is x of z, x of n z transform is x of z with ROC R, let ROC is R. Now multiplication by exponential means a power n x of n. So signal is multiplied by a power n. Exponential means a power n. Now the z transform will be x of z by a, and ROC will become magnitude of a into r. ROC is multiplied by a. This is the property. Let's see proof now. So Z transform of x of n, Z transform of x of n is x of z, which is equal to summation n is equal to minus infinite plus infinite x of n z power minus n, right? Now we want Z transform of a power n x of n. So consider that now Z transform of a power n x of n, which is equal to, so how to write a power n x of n Z transform? Summation n is equal to minus infinite plus infinite. Here a power n x of n z power minus n. So small modification here. I am writing now summation minus infinite plus infinite x of n as it is I am writing. Okay. So here we have a power n z power minus n. A power n z power minus n. In the next step, what I am going to write is summation n is minus infinite plus infinite x of n. Here a z inverse power n. Okay, power n. I am writing. You can write like this. But in the Z transform formula, we should have x of n z power minus n. In that format we have. So I am going to write in that Z transform formula format. Summation n is minus infinite plus infinite x of n z by a power minus n. Is it right? We can write like this because a by a means a power minus 1, minus minus will become plus a. Now by comparing this with the Z transform formula, by comparison of this summation with the Z transform formula, so what we can observe, in the place of z we have z by a, therefore the total will become x of z by a, x of z by a. Okay, right? Now one example also we can do. We know that Z transform of u of n, this we know, Z transform of u of n is z by z minus 1 and its ROC is magnitude of z is greater than 1. This is u of n Z transform. Now, for example, you want 1 by 2 power n Z transform. 1 by 2 power n u of n Z transform. So how much? It's Z transform. So what is the property saying? X of z by a means this is the x of z, the right side is x of z and u of n is the x of n. Following? Now wherever we have z, write z by a. So here a, what is the a value here? A is equal to 1 by 2, right or not? Means z by 1 by 2, z divided by 1 by 2, again z by 1 by 2 minus 1, right? So by doing LCM, we can get 1 by 2 power n u of n z transform is, how much? LCM is here 1 by 2, 1 by 2, 1 by 2 get cancelled, z by z minus 1 by 2, z by z minus 1 by 2. And what about ROC? In the property, what is ROC? The original ROC is multiplied by a. So here a is 1 by 2. So therefore, mod z is greater than 1 by 2 into 1, which is 1 by 2. Magnitude of z is greater than 1 by 2. So this is the meaning of multiplication by exponential. Okay, right? Thank you students. Please watch videos regularly. Thank you all.